Hey everyone, welcome to another video in the installment of programming. Today we're going to talk about output manipulation. Now, output manipulation is not one of my favorite topics. That's because it's purely aesthetic, right? It does nothing to the program except for looking pretty. And so sometimes what we want to see or what the user wants to see looks nice, but given the role that we're transitioning to in terms of like programming and jobs out there, most things don't have a textual based user interface. When I say most things, right, everything's sort of what we call APIs. A lot of it's backend. There's a lot of desktop applications. There's web pages, and none of these things really have output manipulation. Output manipulation was really an old school thing of C++ when consoles were rampant. Nowadays, there's not that much console anymore, but that doesn't mean it doesn't have its place. So it's still useful if you're still writing console apps. It's still super useful for us because we're writing console apps. And so let's kind of get into it. I'm gonna create a brand new project in NetBeans 8.2 C++ application. This one's gonna be called IO manipulation. What was the name of my output manipulation? All right, I didn't really remember. Okay, so in terms of output manipulation, we're going to be using the IOStream library because we're going to be outputting to the console. So we are going to need IOStream. If you're unfamiliar with IOStream or IO, please watch or check out the IOStream or output input video. But we're using a new library today, which is called IOManip. And this one is going to allow, supports all manipulation. And so the thing to remember about IO or console output is that whatever we write to the console is literally what we see. So whatever is in the quotes is what appears to the screen. We can have whatever spaces we want, right? Hello, world. That doesn't work. That, and then I'll do the end line down here. We can have some very ugly looking code like this where it's just on 4 different lines. We have spaces everywhere, but remember, it is okay to do this in terms of the compiler. The compiler is not necessarily going to what did I miss? Oh, ENDL. Compiler is not necessarily going to complain if I spell it right. Hello world, right? It looks perfectly normal. Of course, that's not the case for the code. The code looks completely off, right? So I have all this white space here. I have all this white space here. But again, the point is that white space doesn't matter. So here, it also doesn't matter. Output manipulation is a little weird. So we're going to have a bunch of what we call functions. And essentially what we're going to do is we're going to provide these functions some values. And it's going to change the way things actually look onto the console. And so let me go ahead and just delete this white space because it hurts my eyes. Okay, nice little space. Go around like that. Now output manipulation is typically used to make like tables. So you have like Excel where everything is in nice tabular columns. If output manipulation is typically if you want to output like a bunch of data and you want it to look nice, you want to like left justify, you want to right justify. It's typically for presenting information in a nice to read, easy way. The code's not so easy. All right, let's go ahead and take a single number. So let's create a new number and I'll call it 3.14. I should do that because I actually don't know pi. 3.123456. All right. And so just for now, let's go ahead and just see out num, right, with no manipulation. Right, we want to have a sort of a baseline to what we're seeing on the screen. And so what we're going to see is num colon and a space, and then we're going to just see the entire number 3.123456. All right, there we go. Now the first manipulation that we're going to learn is called set precision. And so ideally it's for decimal values or even for integer values sometimes, depending on how you want it. Now when we're talking about precision, think about the scientific term precision. It represents the number of decimals or the number of significant digits that you want. So let's talk about set precision. Sets the number of digits we want. I should say sets the number of minimum digits we want in output. So I could do cout. And the thing is that because this is output manipulation, these functions that we use are going to be within the output itself. So they're not going to go on its own separate line like it was for the cin.get or the get line that we did in the advanced fundamentals. It's more so going to be within the same exact output as everything else. So here we're going to have the word set precision. That's the name of a function, and we're tossing out the name of function again, right? And so we'll go over functions in depth, but just know that functions in this case, they do something. And so set precision is going to go ahead and take a number. Let's just put in the number 10 to see what happens. Now, set precision on its own doesn't do anything, right? It's manipulating output. So if I put just this, cout set precision, nothing actually happens. So let's run that and check it out. Notice that nothing actually happens. We don't get any output, right? That's because we're not actually outputting anything after set precision. So let's go ahead and output num. So we'll output num, throw on that ENDL. And notice that we get 3.1, 2, 3, 4, 5, 6, right? And so there's basically nothing happened. So what this is saying is that we're basically going to take a maximum of, I know I said a minimum, but I think it's maximum. I'll change it a bit, of 10 digits. Now let me go ahead and set it to 3. Let's see what happens here. Notice that we have 3 digits. So I misspoke. And we're setting the maximum digits. All right, so set precision has manipulated the way that I see num. And so num now has, it still has in this case, 7 total digits, including 6 decimal places or 6 values after the decimal. But set precision just says, hey, wait a minute. I only want to see 3 maximum digits at a time output on the screen. But what if the number is smaller than that? So let's make a new number. Let's say double num2 is assigned 3.0. So we'll say cout num2 ENDL. Notice that I just get 3, right? There's no, it doesn't make it 3.00 because all I've done is set a max. But let's say I do 3.000006. I still get 3. And that's because we're getting 3.00 and then the 6 gets cut off. So that one's a little tricky. Let's change this to 3.56. Notice that we just get 3.56. Let's say we do 3.565. Notice that I get just 3.56. So I still get 3 digits. Now, one important detail that I did not mention or that I did not talk about is that I have a singular set precision, but notice how it affected both num and num2. Set precision is what we call a permanent modifier. Set precision is a permanent modifier. Meaning, once I use set precision, from the second I use it until the end of my program, it will persist. Maybe I'll use the word, whoops. I'll use the word persist instead. Persistent modifier. All right, so when you use set precision and you do want something higher later on, you're gonna have to use set precision again to change that accuracy. So in this case, if I wanted to make num2 or if I want to make num 3 digits, but I want to make num2 5 digits, right? I can go ahead and throw a set precision here with the number 5, and then num2 will now have 5 digits, but then everything after num2 will also be limited to 5 digits, right? It's persistent from the point of when I used it, unless I do another set precision. So we'll see here, we get 3, and then we get 4 because there's not a 5th digit. right? One thing you also notice is that there's no rounding. So if I put 99 here on my num2, and notice I get 3.56. Oh, it did round. Does it only round 5655 56? That's still 5 digits. There we go. 6 digits. 5655. You'll notice that it doesn't round when it's a 5, which is not the same thing as math, right? In math, if it's 5 or higher, it rounds. But if I do 6 right here, notice that it does round. We got 6 5 5 6 5 6, right? We got 5 6 5, and this one did round. So even if I had like 51, the one still rounds. So it rounds very oddly, right? It rounds not to the next digit, but next to the entire numbers afterward to that place. So what that means is it's rounding, if it won't round on 50, right? Because that's right in the middle of the 100th place for that specific area. Notice that's still a 5, but it does round if it's 5 1. So we get this nice little 6 here. Also, same exact thing. If it's 500, it will not round. But if it's 501, because it's 501 out of 1,000, it now rounds up to a 6. And so the rounding properties are a little weird when we use just set precision. Fortunately enough, we don't ever just use set precision. Having significant digits is all fine for output if you're doing something mathematical or something scientific. That is extremely rare to occur. Instead, we actually combine set precision with another persistent modifier. So we combine set precision with fixed. Now, fixed is another reserved word, kind of like set precision is reserved for setting the number of total digits I have. Fixed is actually changing the way set precision behaves. When using fixed with set precision now refers to decimals. I spelled set precision wrong. All right. What does that mean? Well, right now when we use set precision, it was affecting the total number of digits. But when we throw in the keyword fix, it's now going to be manipulating just the number of decimal places. So let's go ahead and try that. We'll do cout. Notice that I already have set precision 5. So instead, I'm going to add the keyword fixed. I'm going to do a set precision just for, completion's sake. We'll call it 4, which is 4 decimal places. And let's output num2 again with an ENDL. Run that. And notice that I get 4 decimal places. Let's change it up. Let's make it 5 decimal places. Right? Because I didn't want these two happen to be the exact same number. I didn't want that. So notice I get 3.56555. So I get 5 decimal values after the decimal place. And so that's because I use it with fixed. Now I can never go back. Once I use the keyword fixed, that's it. It's weird. It's literally fixed within the output. So I can never go back to an unfixed state. So once I decide if I want to use exactly the number of digits or if I want to use the decimal places, I'm pretty much stuck with whatever my final decision is. But in application, that's totally fine. Usually someone wants things to be accurate to a decimal place, usually 2 decimals for money, right? So if you're doing anything with currency, you'll have 2 decimal places, or if they're doing something scientific, you'll have set precision to be based off the number of significant digits, right? That's usually not that often used. Instead, we actually use, in this case, the number of digits. Now notice that we had there are no rounding, right? Because we had 5 digits after the fact. But let's go ahead and see what happens if I change this to 5555551. Notice that the same rounding rules taking place. So in this case, I'm having 5 digits, but the same rounding rule after the digits took place. Having it's non-inclusive, right? So 5 isn't included, but anything higher than the halfway mark is included. So 5 and lower aren't part of the rounding. They don't round up. It just kind of truncates or rounds it down. So we have set precision, which manipulates the number of digits. And when I use it with fixed, it manipulates the number of decimal places I have. All right. But let's go ahead and see as if I have currency, right? So typically for currency, we use set precision 2. And so that, again, it's just the way we show it to the user. My number never changes. So num2 never changes from this value. Num2 is always going to be 3.5655551, unless I physically change the number here in the code. I'm just kind of modifying the way I see it on the screen. And so I would do something like this. I would say cout fixed. I actually don't have to do fixed, but I could do cout set precision 2. And I'll say total amount of money, and we'll output num2 again. So I'm going to chain all of this output at once. The ordering doesn't actually matter. I could take the text right here, and I could actually put the text in the front if I wanted to. That way I could do something like that. And then let me delete this last one. Right, I could do something like that, so that's way the set precision is right next to the number if I wanted to. And then notice that now I just get it accurate up to the second decimal place. So that way it kind of mimics the way money works. Now, one typical issue that I usually always see is the ordering of when to use these modifiers. Right, so the modifiers don't take place until you actually use them in the code. So what that means is I typically see sometimes people do this. They would put the modifier after the number because technically it's a flow, right? And I can see why. The program flows from the right to the left. And so we're sending all this output to cout, right? We're saying this output, num2, and set precision. The problem is the modifier isn't getting applied to the number because it's after the number in the ordering of the code. And so when I run this, I'm just going to see num2 with precision 5 again. So 3.56556. That doesn't change. And that's because I had a set precision up here. So if I do want to change something, that output has to be before. And so there I can put the modifier before my actual output and we get exactly what I want for money. And so this is what we do when we deal with decimal places or if we want significant digits. Now let's kind of work with columns. What if I wanted to make a nice, neat column, right? So that way, no matter what, I always have sort of the same exact width for all of my numbers, right? And so let's go ahead and try that out. Let's let's create another number called num3, and let's make that like 5.86412. Doesn't really matter what it is. So we have num, which is this number. We have num2, which is this long number. And we have num3, which is this number. What I want to do is I want to output each and every number in like a nice tabular field. So if I wanted to do that, we're going to use set w with a value inside to create a set column width. Now the thing is, we have to kind of think about this in like in our minds, because nothing actually, we don't see anything on the screen. Instead, what we see is sort of we see actually nothing. We just see the console and then some space and then output and then some space and then output. But you have to imagine Excel columns, right? Every column in an Excel document always has a designated width, and we're trying to simulate that exact thing. And so we're going to go ahead and use set w, cout set w. Now I'm going to change this to num of characters. So first we have to decide, well, how wide do I want my column to be? Well, let's just say 10 characters, right? And then let's output num1, and then let's output num2, and then let's output num3, just so we see what happens. Now, one thing I am going to point out here before I run this is that set w, unlike fixed and set precision, is not a fixed modifier. Or sorry, not fixed, persistent. Meaning, whenever I use set W, there is no num1. Whenever I use set W, it only works for the next output. So in our case, set W is going to affect the very next thing, which happens to be num. Doesn't affect num2, it doesn't affect num3 because it's not persistent. It doesn't travel along num1 and num2 and num3. Just applies to num. Similarly, sometimes I see people putting like a set W at the very end, which is fine. Right? Sometimes they put like a set W right here. And then they have an output down here. Cout num2. Or something like that. The next output from the line before, right, which is the set W on line 50, is being applied to the num2 on line 52. So the very next output is way down here. It's not necessarily on the same exact line, which is line 50. And so let's go and run this and see what happens. All right. So it looks like a bunch of random numbers. In fact, did I have that right? Cout total amount of money. I do have an end line. Okay. You'll notice that I have this blank space right here, right? I actually have 3.12, which is num. I have 3.57, which is num2, and I have 5.86, which is num3. Right, but you'll notice that they have all this space right here. In fact, if I count the number of white space there's going to be 6 characters. So I have 1, 2, 3, 4, 5, 6. And then my actual number that I said have a certain width is 3, which is, sorry, that's 7, 8, 9, 10. So now we have 10 total characters dedicated to that one number. But then you'll notice that 3.57 and then 5.86 are right next to it because that's how I output it. I output it all right next to each other. So what if I wanted to put those in columns? Well, let's add set W's before those. Set W10. And then I'm going to move this one to the next line because it's getting kind of packed. Set W10 again. And then I'm just going to get rid of this set W because it doesn't look proper right there. And then we'll put the set W10 down here on line 53. All right. So that way I have 3 columns with the 3 set W's, and then I have a new line with just 1 column. Now when I run this, I've reserved 10. Oh, what did I mess up? I forgot this. I forgot my output. Now when I run this, notice that I have a total of 10 characters reserved for one number, another 10 characters reserved for the second number, and then another 10 characters reserved for the third number. I went to the very next line, and then I got another 10 numbers reserved for that other output, right? And so set W not only set the width of everything for us is to 10, but it also right justified everything, which is fine if that's the way I want to justify it. Let's go ahead and put some headers, right? So notice that I have these columns, but I don't have headers, so it doesn't really look like an Excel document. But let's go ahead and add headers. And headers are basically names to the columns. Now these are just going to be junk names, but we can say like set W10, and let's call this first column USD, and then let's call this second one set W10. Let's call it EU. I'm just making up things for what we could call them, and let's call this one pesos. I actually don't know that many currencies. ENDL. All right. So notice that not only with numbers, but for anything that I output to the screen, I can kind of change the width of pretty much everything. So here I have a total of 10 characters. I have 7 reserved for the column, so it's just white space. And then I have USD. I have another 10 characters, and then pesos, and then another 10 characters, and then another 10, another 10. But now you'll notice I have this cool columned output, right? So I've just manipulated the way I have it presented, but in reality, the code kind of doesn't look like that. So set W lets me make these columns. Now, one thing we're going to add to the set W is something called justification. So what if I don't like the way it's justified, right? What if I don't like the way we have right justification? Well, I can change the way I justify things by using my special keyword called either left or right. So use left or right to change justification. The left/right is a persistent modifier. So in fact, everything that we talk about is a persistent modifier except for, in this case, set W. Set W is probably the only non-persistent modifier. We have to apply it to every column that we want to do because it specifies a column width. But let's say I want to change the justification of the column right here. Well, we can just add the keyword left. And so now we'll read the whole line on 55. We're going to go ahead and do a left justification on every set W ever, pretty much, and we're going to output num2. So now you'll see we actually have 10 reserved spots, but now we're going to the left. So if I actually were to output something after this, like num3, we'll see the following. We get the 10 characters that are reserved for that output, which was num2, and then we just get the num3. Now this doesn't have 10 characters associated with it, right? I didn't put a set W on 5.86, so instead I'm just gonna, if I output again, I'm gonna get a number right next to 5.86. So if I were to output, let's say num3 once again, notice I get both those numbers just right next to each other, right? There's no space, there's no column, there's nothing like that, because I didn't put a set width on num3 right here, so there's no column. But I did left justify the num2. And so in fact, if I moved left up here instead, it's now going to change all the justifications to left. So now it's changing my USD, my EU, my pesos to left, and it's also changing all my numbers to the left-hand side. At this point, it's pretty much preference as to whether or not you want the values to be aligned via the left side or if you want the numbers to be aligned via the right side. It doesn't actually matter. That becomes user preference at that point. All right, I'm gonna get rid of this left up here though, because we already have a left down there. All right, so I'm actually gonna move this line of code on 55, and I'm just gonna move it below 60 because that's where we talk about justification. So on line 58 right there. All right, now finally, the last thing we have to talk about is something called set fill. Now set fill is another modifier, right? So we've had the modifier that modifies my column size if I want to create a column. I've had the modifier that modifies the number of digits and the modifier that does the decimal places. And we have justification, left or right. This modifier is basically a filling modifier. It's actually super handy if we want to create like lines or if you want to just fill the empty space that we've created with set W, all right? So set fill, it affects with an A, affects all set W's that are used. Fills in any blank space from set W, right? So set fill only works in conjunction with set W. If we don't have a set W, set fill does nothing. So pass in a single character to fill. So let's go ahead and take all this output that we had, which was my cool little columns, and I'm gonna move it down here, right? Because I don't want to mess up our nice little columns that we have up here, but I am gonna mess them up down here. So all we're gonna do is we're gonna throw in at the very top, let's go ahead and throw in a set fill. And I can choose a character that I want to fill with. Now remember that when it comes to a character, it's single quotation marks. So in this case, we'll have 2 quotation marks, and then let's just choose the character dash. right? So we'll go ahead and fill it with a dash. And so what's gonna happen is from this point forward, also a persistent modifier. From this point forward on line 64, anytime I use a set W, it's basically going to fill in that set W with whatever open space there is with a dash. Let's go ahead and run this. So I got my first output, right? It's nice and neat. I did a left justification here, which kind of looks ugly, but that's okay. And then the left justification is permanent, right? So it persists, hence why these ones are left justified. But notice that all the space is filled in with the dash, right? Let's go and change that to a star. And then when we change that to a star, it's going to fill in every single bit with a little star. So now the question is, how can I use the set fill to make horizontal lines? Well, I'd have to do something like this. Cout set fill. All right, let's go ahead and fill in with a line in this case. And then let's do set W. And let's make a 80 character long column. And then a brand new line. Now, this is not going to work. I'm going to hit run and we're going to see it not do anything, but we'll figure out why. See, we'll have that line. There's that new line right there, right before the run successful, but nothing happened. Remember, set W only affects output. There's no output after set W. So I have to output something. Easiest thing to output, just an empty character. So we're saying, all right, take this empty character, create a width of 80 characters long, so an 80 character column for an empty character, right? There's no output in there. I could put a space if I want to, but I don't need to do that. We're going to then fill in everything, which in this case is all 80 characters. We're going to fill in all 80 characters with a dash. Go ahead and run that. And notice I get a nice 80 character line that sort of looks like just a horizontal line. And so that way I can output this line very, very quick and very, very easily without actually having to type out 80 entire characters. All right. So in terms of output manipulation, there's really 5 things that we have. We got our set fills, we got our left or our rights, we got our fix and our set precisions, and those are all persistent. Once I use them, it's going to be like that the entire length of the program when I'm outputting. The exception is the set W, which only affects columns. All right, so now that being said, let's go ahead and commit this code out. Created the code in my repo. If you're ever wondering like how I actually confirm it's in my repo, you'll notice that next to IO manipulation, there's a cool little cylinder, right? It's right next to the IO manipulation project. And that basically lets me know that, hey, this project is within my repository. So I'm okay with that. So let's go ahead and add this code. So git add all. Let's go ahead and commit this code out. So we're going to go ahead and adding output manipulation code. And let's go ahead and just push it, which again is the upload. Push origin master. And that's it. All right, so thank you guys for watching. See you next time.